Hi everyone, and thank you for watching my video. I haven't made a video about mitochondria in a while, so I decided I would continue my series of videos about mitochondria. And when I talk about mitochondria, I talk about it from different angles, and I layer my information because I want to build to something bigger later. Now, in this video, the main focus and what I'm going to talk about in this video is the four mitochondrial complexes with the emphasis on the first two mitochondrial complexes. And I'm going to talk about this from the foundation of my information is going to come from a book. I'll drop the book in the description box if you want to check it out for yourself, and also from information that I've attained from Dr. Jack Cruz. Now, the book, it focuses on mostly biochemistry, but Dr. Jack Cruz, he talks about and focuses more on biophysics. When you're learning about something, it's good to understand it from as many perspectives as possible because nothing's in isolation. Everything is multi disciplines. Just like we all have very complex personalities that make us the one person that we are, and this is no different. So yeah, I'm going to talk about the four mitochondrial complexes in this video. I'm going to focus on the first two, but I'm going to talk about four, and I'll end the video by talking about some qualities and some things that can make the mitochondria work better and work worse. Just talk about some overall general things in that regard. So let's get started. Now, let's start by what is a mitochondria. Let's start from Square one. A mitochondria is a bacteria that's in each one of our cells. There's hundreds to thousands of mitochondria in each individual cell of our bodies, and the mitochondria, they make energy for the cell. And mitochondria are really special because they don't really seem like any other biological organism. They're more like a nuclear power plant, in the way that they make energy, and they're like a supercomputer because they can compute and they can pick up and they can process whatever information and whatever is in your environment. They can sense. It's like a sensor. Now, I mentioned it's like I said it was like a power plant. And what I mean by it's like a power plant is because it can make all types of energy. Mitochondria can make heat, heat energy. They can make electric energy, like actual electricity. They can make chemical energy. They can make water. They're very versatile. They make different energy based on the environment and the circumstances that they're in. So some really complex, intelligent uh, organisms that are inside of us. Mitochondria, they behave based on the environments that we're in. Mitochondria, they know where you are. Because they can sense the environment. And what I mean by that is like if it's really cold outside, mitochondria, they can pick that up, and based on the temperature outside, they modify their behavior. They, instead of absorbing light, because that's one thing they can do, they can absorb light and process light and use the light as a type of energy and electricity. They heat the body. Heating the body, you have to heat the body in order to stay alive. So they can make heat for the body in that case. Now, if they're in an environment where there's very strong light, especially regenerative UV light. UV light is the main light we use to regenerate, and your body your body's feeling it and absorbing it and picking it up and taking it in. Your mitochondria is gonna start using that light and absorbing it and processing it to make energy and for regeneration and all the different purposes that the body uses light for. And if you're, let's say, you're in an environment where it's full of oxygen, then the mitochondria are gonna react differently in that environment. And oxygen is food for mitochondria. It's one type of food for mitochondria. Oxygen is actually the electron acceptor. So the oxygen is like at the end of the chain of the mitochondria, and its oxygen functions as a magnet to help draw in more electricity and electrons that the mitochondria process. And I mentioned that mitochondria act differently in different places. Um, we all have different types of mitochondria, each of us individually. And I was fortunate enough I was able to get a DNA test to find out my mitochondrial haplotype. And what that means is that I can learn where the majority of my mitochondria come from. And by knowing that, now what region in the world where the majority of your mitochondria come from, you can know what environment your mitochondria were adapted from, where they originated from. And theoretically, if you were to put yourself back into the environment where the majority of your mitochondria come from, then your body can make energy at its highest potential, because that's where its genetics, its DNA is where they come from. And for me, the majority of my mitochondrial DNA is from West Africa. About 82% of it is from West Africa. So theoretically, if I wanted to heal and regenerate faster, or give my mitochondria a boost, that would be a good area to go to for me. Now, you know that even though even with that data, it's still a little bit flawed, because that environment right now is very different from the environment that the mitochondria came from. Where they get the information from with mitochondrial DNA is they trace it through the maternal line. They track your maternal mitochondrial DNA on down. They say like a few million years they track it. So if you were to try to go back to that area, it may be based on millions of years of data, million year old data. And of course, the way that area was a million years ago is way different from the way it is right now in this day and age. But you're likely much better off in that area than the area that you're in now. Well, I'm speaking for myself, because I'm very far away from East Africa. So there would likely be a very high benefit for me to go there and test that theory out. Okay, so let's talk about the mitochondrial complexes. Let's start with complex one. What does mitochondrial complex one do? Mitochondrial complex one is the complex. Mitochondrial complexes, they receive light, and they also receive electrons that we get from food. They receive electrons from the ground when we step on the ground with our bare feet. They receive photons, from the light that we see. And the first complex, the type of chromophore that it has, chromophore absorbs light. The chromophore for the first complex, it's a UV chromophore. So the first complex is designed to receive UV light. So it can take UV light and process UV light and make energy. The first complex also is designed to receive really simple, really simple food like sugar, carbohydrates, because usually really simple food grows in a high UV light area. And because this is the first complex on the chain, it's it's easier than the other complexes for electrons to spill or to get jammed up and not enter into the chain properly. And when these electrons spill, it creates, they can, they're highly reactive. So they can create something called a free radical. And what's a free radical? A free radical, it's an unstable molecule, electron, and it can interact with surrounding tissues or even parts of the mitochondria and damage the mitochondria. And a lot of people think that this is part of aging, you know, excessive free radical production. But free radicals have a good point, a good side and a bad side. I think it's situational. It's controversial. Um, free radicals can also signal for the mitochondria to kill itself if it's too weak, or for mitochondria to make new mitochondria. I actually made a video on that, and I'll drop that video in the description box below if you want to check that out. It was pretty cool. Now, with the complex one, it uses it takes electrons from when we receive food electrons. When it's reduced, we receive the reduction. The reduction is called NADH, and the electrons are stripped from NADH and are processed through complex one. And here, when they're processed through complex one, uh, what happens is they strip, they reduce the electrons, and they send the electrons to the next complex two. But after the electrons reduce, protons are pumped outside into the membrane of the mitochondria. Protons are pumped, and protons they're used to make ATP and ADP and create energy. And I could make a whole other video on that. Maybe I will, about protons. Now, with the first mitochondrial complex, what does it all have in common? What does it all kind of mean, or what can you take from it? With the first mitochondrial complex, it processes high energy light, like UV light, and it processes simple food, simpler energetic food. And what does this have in common? What it has in common is that these things happen in places that have very strong sunshine, places that have very long light cycles, because high carbohydrate food, sugary food, it grows in very strong sunshine places. And in order for mitochondrial complex one to work at its best, you need high energy light. You need UV light. And so if you're in a place where there's not much UV light, and you're eating like really sugary food, or not sugary food, but simple food, carbohydrate rich food, then complex one won't process it that easily in the absence of UV light. So So I guess you could say that complex one is like a summertime or a region where very strong sunshine region complex. That's his specialty, I guess you could say. Now let's talk about complex two. Now with complex two, it's quite different from complex one. Complex two, it receives NADH, what's food's broken down to, the electrons food's broken down to, and something called FADH2. Now, what it does with those, it strips those electrons, it processes and strips those electrons, and it what's different from this complex with complex one, it does not pump protons. I mentioned complex one pumps protons in order to make ATP, ADP. But this complex, it doesn't pump protons. From what I've learned, but I won't go too deep into it because I don't understand it fully myself, is that it's actually a proton acceptor. It accepts protons, and I'm thinking it has to do with the mitochondria making water at the fourth step. But yeah, it's a proton acceptor, and also the at the second complex, it processes high energy food and high energy. It Yeah, it processes high energy food, but food that's low in light but very high in energy, high in electrons, such as fat and proteins. So in complex two, it it scripts the electrons from the food. It doesn't pump protons, so it's not leaky either. It's not leaky like the first mitochondrial complex. It doesn't leak electrons, so it's pretty safe in regards to that. Leaky electrons. They think it's a big part of aging, and they think it's a big part of what damages the body from the inside. And this complex, it doesn't really leak electrons. And at this complex, because it specializes mostly in fat and protein, it's assumed that the body prefers fat and protein because this they said the mitochondria 70% of it utilizes fat for fuel, so it's like its main fuel, its main way it processes electrons to make energy. And with the with complex two, the way it's different from complex one. Complex one, I said that it was something like summertime or tropics, like really strong light area or really strong light time of year. But this is kind of the opposite of that. It's low light, so it deals with low light. It senses and picks up low light and uses that light to make energy. And it also deals with very high energy foods, and this only happens in under circumstances where it's very cold and or where the light cycles are very short. So I guess we could say complex two is a short light cycle complex. It specializes in that, and it works best in that it feeds and utilizes high energy food under those circumstances. Once if it's picking up and sensing and observing those circumstances. So that's complex two. Now let's talk about complex three and four, and I won't go. I'll just skim over these because the my main thing I want to talk about in this video is complex one and two. But complex three, like complex three, it utilizes something called coenzyme Q10 to to strip electrons, and it actually pumps protons. One pumps protons, two doesn't pump protons, three pumps protons to make ATP, to make energy for the cell. And complex complex three, it complex three, it's also leaky like complex one, so it can leak electrons, and it can get a little messy. And uh, what it does, it breaks down electrons. It sends the electrons to complex four. Complex four, its main job is to make water. So complex four, it strips electrons, it pumps the protons outside, and it complex four, it processes the electrons. It uses electron energy, and it fuses it facilitates a reaction, and it makes the water. It provides the energy to combine the two hydrogens to the oxygen to make water. And oxygen is at the end of this chain, and oxygen is the terminal electron acceptor. And they say there's a fifth mitochondrial complex called the ATPase, but that's debatable whether it's actually a mitochondrial complex or not. So now this portion of the video, I'll talk about some things that speed the mitochondria up, that slow it down, that help it, that hurt it. Now, with the mitochondria, uh, UV light, high powered light, speeds the mitochondria up. It makes it work very efficiently. It UV light is like a super powered light for the super energy for the mitochondria. It can really use that energy for very great benefit. And another factor that speeds up the ability, and makes the mitochondria more functional, is cold. When the temperature drops, the mitochondria begins to produce more heat energy. It makes the mitochondria produce heat, and when mitochondria produces heat, um, it it shrinks. It shrinks the mitochondria because heat makes the molecules move around a lot more than cold, and it shrinks the mitochondria down, and the complexes are closer together. And the closer they are, the faster it can pass energy from complex to complex to complex. So it's way more efficient when this is happening, when this goes down. So um, when your mitochondria sense cold, um, that can speed up the energetic processes of mitochondria. So UV light, strong light, and cold, they those are two factors that make a mitochondria process energy uh, a lot faster, a lot more efficient. And yeah, also, with the mitochondria, when the cold makes the mitochondria make heat, it also makes the mitochondria make infrared light. Infrared light is very regenerative for the body. So when the mitochondria is forced through cold to make infrared light, it's healing itself. And also with the mitochondria, it's making water, and the water that a mitochondria makes at complex 4 isn't just plain old everyday ordinary water that we get in the faucet. It's special water. It's a water that's inside of our cells. And the mitochondria is basically pumping the cell full of water. It's making itself. You are building yourself from the inside. So the water inside of your body doesn't necessarily come from the water that you drink, but from the water that your mitochondria are making. Okay, so I'll stop the video here, and we'll more to come. Talking about mitochondria, real interesting, right? Thank you so much for watching my video. I appreciate and love you, and thank you so much. I hope everything is really great and wonderful for you. So you all have a beautiful day, and for me it's nighttime, and I got the red light, and I'm about to go to bed. So much love out there. Bye.